Thank you for coming. My name is Liz Tomaszewski. Among other things, I'm a sustainability coordinator on campus. I'd like to welcome everyone to this event, which is part of many events that WPI offers for its celebration of Earth Day, which is called Earth Fest, which runs pretty much the full month of April and includes, among other things, speakers, volunteer activities, and other competitions. I'd like to introduce to you now Christine Drew, Assistant Director of Research here at Gordon Library. Thank you very much.
Welcome everyone to the third annual Sustainability Poster Competition. We're delighted to have it again here in the Gordon Library and to see so many students who've engaged in research, many of them I know using the library very much to develop these projects. And I also want to thank you and also welcome you to our Ben Franklin exhibit. Ben himself was a proponent of fresh air and environmental topics as well. And I know there's a cook stove. The Engineers Without Borders have a cook stove exhibit where they're interested in restoring home. Ben Franklin was as well, and many of you may know he's invented the Franklin stove. So keep that in mind. Sustainability topics have been of interest to Americans for a long, long time, but you yourselves are pioneers for the future of sustainability, and we look forward to the promise that you give to all of us. I want to introduce the Dean of Arts and Sciences, Karen Oates, who will be here to welcome you to this competition. Thank you for being at the library today.
Well, good afternoon. It's really fun to be here with everyone. It's a great way to celebrate Earth Fest and Earth Days for this great occasion. And it's great to see students who are putting their creativity and their research skills to work to help us sustain a wonderful environment here and especially our planet. So we're really very proud here at WPI of the kind of work that we've been doing. And Liz really needs to be commended for really spearheading so much of the facility work, which is extremely important on campus, and the work with students, which is, of course, the most fun. So a couple of things that we really are very proud of. So with the help of this community, we've been able to achieve some very important milestones. We are one of 52 university campuses across the nation who received a report card grade of A or above for the Sustainability Endowment Institute's National Green Report Card. There were only 52 campuses, and we are one of them with grades in the A category. That's pretty impressive. WPI is also among Princeton Review's Greenest Schools and the Sierra Club's campus recognitions for being a green campus. Right now we're constructing our third LEED certified building, and if you haven't had a chance to go and look at it, you really should. It's as it is being built, it's really fun to look to see how we're taking advantage of the hillside and the geography of the land. Our faculty are at the forefront of research in renewable energy, natural product development, solar generation, metal research, electric motor generation, and we're beginning in sustainable farming. We've entered into a partnership with the Institute for Energy and Sustainability, Clark University, and the town of Lancaster to bring electric vehicle infrastructure to this area. That's something that's really pretty cool. This is really part of who we are at WPI. We're here, we solve problems that have immediate concern for our region and for the nation and the world. So well beyond those individual courses that faculty instruct, well beyond the modules that we put into the courses on issues related to sustainability, we have things like our Great Problem Seminar, our IQPs and our MQPs, which take directly on the challenge of sustainability. I think it's actually in the minds and the passions of the faculty and students here to really try to engage in this type of work. We know it's important. We know it's important to our future. So this afternoon, we'll be selecting winners for the sustainability poster competition. But quite honestly, just by virtue of doing what you do and having a poster and having other people look at it and think about what you're doing, you're helping us kind of think about new ways in which we can look at this campus and look at the region. And so you should all be commended by that, because it's really those ideas that you help generate that are really of great value. So we need to really thank our judges. It's a hard job, and you really got your work cut out for you. But our judges today, Rob Kruger will be one of our judges. Rob is the director of our Environmental Studies program at WPI, doing an awesome job letting students know what they can study and how they can study issues related to the environment. Dr. Pearson from Clark University is here, and we want to thank him for making the trip. Chris Noonan, a senior program advisor at the Institute for Energy and Sustainability, is here. Thank you. Susan LePage from our Environmental and Civic Engineering program. Linda Liu, who is our VP for, our VP for Government and Community Relations. Laura Matthews, I saw, our Associate Professor of Biology and a member of our Environmental Studies program. I saw Rick Sisson, the Dean of Graduate Studies, and Chris Wolbe, who is the Associate Dean for our first year experience and Head of Chemistry and Biochemistry Department. Again, thank you very much. You really do have your work cut out for you. And I think I want to end by saying that when the posters come down, we're all going to go on our merry way. But we need to really remember that the work that you're doing here and the work that you've done to help build a better is really about building a better America, a very just America, and an economically stronger America through issues related to sustainability. Science, engineering, and social sciences, the research that we do really makes a difference. But quite frankly, looking at the students here, you're the ones who are really going to make the difference. You have a legacy that you're going to have to think hard about, and we hold that legacy in your hands, and we thank you for that. Thanks.
Thank you. My name is Rob Kruger, and I'm the director of the Sustainability and Environmental Studies program. And I want to thank all the participants today for putting forth such great projects for us to evaluate and enjoy and celebrate the work that the great work that our WPI students do. I'd also like to thank once more the judges for participating in this process, and the library for hosting, and most importantly, Liz Tomaszewski for helping organize it. Thank you, Liz. So I don't know how I got the great job of announcing the winners. So we have identified the first and second place winners, and it is team number 6, Organic Solar Cells Like It Rough, Nathan Nesbitt and Daniel Mueller. The second place team is team number 12, Biofuels from Mycoalgia Etlia, and something I'm not going to try to pronounce. Congratulations, Andrea Tarbert and Lynn Mann. Once again, I want to congratulate all the participants here today. Some outstanding projects, and again, we really appreciate your work. There are certificates for everyone, and the first and second place prize winners, if you'll wait around for a few minutes, your special certificates are being created as we speak. Thank you again, and enjoy the rest of the day.
I'm Nathan Nesbitt.
I'm Daniel Mueller.
So what we did here is put this project on. So our project is on organic solar cells, a very cost-effective and environmentally friendly replacement for silicon photovoltaics. So the idea here is we have a monolayer of I'll let you describe it.
All right. So what happens is we attach these dye molecules onto the surface of a very thin gold substrate layer, and that's attached with a small acidic molecule called NUA. And on top of that, a porphyrin is attached, which has a very high quantum yield, so it's able to very efficiently transform photons into electrical energy. The problem with these is that because they're built as a single layer of molecules, they're very thin and they do not collect a lot of light in general compared to a regular photovoltaic system that's based on silicon photovoltaics. We did figure out a way, though, to increase the absorption.
So we deposit little nanoparticles onto the surface, which increases the effective surface area, so that there's more surface area for the monolayer to be present on, per square centimeter, and that gives us a higher absorption. We look down here, we have images of the smooth seed particle and then the rough growth of the nanoparticles. So we put porphyrin onto the smooth and onto the rough, and then measured. So our first batch gave us this for the smooth and these values for the rough. You have photovoltage and photocurrent. So when you average these values, you get a 56% increase in voltage and a 62% increase in current. Looking at our second batch, the growth process didn't work out as well, and that's reflected in the voltage and current measurements. There was an actually negative increase in voltage, but a positive increase in current, kind of all scattered together. So there seems to be consistency between the topography that we're getting and the photocurrent photovoltage measurements that we made.
Okay, and so what are the applications for that?
The idea here is it's an inexpensive replacement for silicon photovoltaics, and that's the purpose behind it.
Thank you.
Hello, my name is Andrew Tarbett and I'm a senior in the biology department.
I'm Ben Binnenberg. I'm also a senior in the biology department.
This is our project about using microalgae to produce biofuel. 40 years ago, economists predicted that oil was going to run out. Recently, articles were released in scientific journals saying that we may have reached our highest amount of oil that we can find in the earth. So obviously, in order to keep our culture running the way we have it running now, we need to find an alternative energy source to keep up with our needs. So our project looks at using microalgae to produce biofuel feasibly. We had 3 different questions during our project. Our first question investigated using agricultural waste to supply algae with nutrients to allow them to grow. This was actually done by the grad student in our lab, Professor Weathers, and she discovered that it was the effluent from agricultural waste did indeed allow algae to grow. And our project looked at using light and temperature and looked to see how algae are affected by the different light intensities and temperature, because we all know that light and temperature differ from different regions across the world. So it's important to find the specific range in order to have maximum oil production from the algae.
So the algae used in our study is Entalia oleabundans, which is the microalgae that produces oleic acid, one of the ideal precursors to biodiesel because of its unsaturation, which yields stable fuel with ideal ignition properties and overall fuel quality. So the big picture of our project is to feed agricultural waste into an anaerobic digester and yield a liquid waste effluent that can be fed to the algae as part of their media, and they can be grown in either closed reactor systems or even open algae ponds. And when you harvest the algae, you can extract the oil from Entalia oleabundans, and then through a chemical transformation process, you get biodiesel. And the work done that we were given looked at different compositions of waste effluent, and in all sorts of compositions was shown that the algae still grow and they still produce oil, and they're producing 18-1, which is the correct oil for our biofuel prospect. So we know that we can feed them waste and they still grow and make oil.
So our our MVP project looked at using 3 different temperatures and 3 different light intensities and their effects on the growth of Ethlia. We used 15 degrees Celsius, 25 degrees Celsius, and 35 degrees Celsius to get a good range and try to reflect the weather patterns that are here in New England. Our light intensities were 70, 130, and 200 micromoles per meter squared per second. And our results show that no matter what temperature and light intensity, you can still get Ethlia abundance to grow. Our 35 degrees was a little less successful than our other 2 runs. Within a week, they kind of died off and stopped producing oil, and the oil that was produced was very low. However, in 15 and 25 degrees, they were able to grow, and they reached really good levels of oil. So from our conclusions are that it is possible to use algae for biofuel production, which is really good for our economy and for our modern society, because we have to be able to find a way to get away from oil and get independence.